The paper introduces a novel approach to detect contradictions between high-level requirements in the software verification process, particularly in aviation system development guided by the DO-178C standard. This method transforms high-level requirements into logical expressions and utilizes a SAT solver to identify inconsistencies. It integrates with the Dynamic Object-Oriented Requirements System, DOORS, to systematically analyze and manage requirement conflicts, focusing on both functional and non-functional requirements. The proposed methodology is compared to existing methods in Table 1, highlighting its unique features and advantages. The study leverages IBM Rational Doors and the Doors Extension Language, DXL, to automate the review process, reducing the time spent on reviewing high-level requirements and minimizing potential reviewer errors. A dataset was created using requirements presented in two different formats, a common avionics software requirements format and a customized version of the Gherkin language. Requirements were rigorously parsed based on their respective grammars, facilitated using ANTLR4. The data dictionary plays a crucial role in organizing the dataset, with a data definition table, DDT, aligning with the purpose of the data dictionary, as shown in Table 2. The study aims to contribute to the existing literature by providing a different approach to the review process in areas with similar software requirements, focusing on detecting and managing requirement conflicts. The proposed method is designed to be automated, making it more efficient than manual review processes. This novel approach has the potential to significantly enhance the efficiency and accuracy of the software development process. The proposed method for analyzing logical contradictions between requirements with common operations using a SAT solver consists of three phases: converting requirements to logical expressions, conflict analysis, and reporting. The conversion phase involves parsing requirements using ANTLR4, translating them into logical expressions, and simplifying complex sentences. In the conflict analysis phase, the algorithm identifies contradictions between requirements by comparing their logical expressions and checking for inconsistencies. The reporting phase utilizes Jenkins to automate the build, test, and deployment processes, providing continuous integration and delivery. Employees can review the HTML report and request necessary changes. The research paper also discusses the development of a novel method for identifying contradictions within high-level requirements, HLR, in software development. This method combines parsing algorithms and SAT solvers to analyze requirement pairs with shared operations. An example of HLR requirements is presented in Figure 4, which are then analyzed using a SAT solver. The hypothetical syllogism rule is introduced to discover nuanced contradictions, where if P implies Q, and Q implies R, then P implies R. A SAT solver REST API is used for contradiction analysis among requirement pairs with shared operations. The request contains requirement pairs translated into logical expressions and is sent to the SAT solver REST API using the SymPy library. If there is no solution set, it returns a response indicating the presence of a contradiction. The paper also describes the contradiction analysis report generated at the end of the study, which is connected to Jenkins automation and includes the analysis results of all compared requirements. However, the method has certain limitations, such as requiring the creation of a grammar for requirements formats using ANTLR4 and additional implementations for logical transformations. Since the method does not incorporate any natural language processing technique, the transformation of logical expressions in requirement sets written in natural language must be done manually. The study concludes that the presented method can significantly reduce the time and effort required for manual analysis of HLR requirements and can also identify nuanced contradictions that may be overlooked by manual inspection. A novel methodology for detecting logical contradictions in high-level requirements, HLRs, for software development projects, particularly avionics systems subject to DO-178C certification standards, is presented. This approach leverages logical expressions and SAT solver analysis to streamline the verification process and reduce the workload associated with reviewing complex requirements. The method's effectiveness was evaluated using a dataset of 25 HLRs covering avionics, with results demonstrating its ability to identify contradictions between requirements. A comprehensive review of existing literature on managing requirements conflicts and inconsistencies is also provided, encompassing approaches such as automated traceability, goal and scenario-based conflict management, and semantic technology for compliance checking. The importance of addressing these issues to ensure consistency in software development processes is highlighted. The evaluation section reveals that participants with 2 to 5 years of experience in HLRs struggled to identify contradictions when operations served as conditions for other requirements. In contrast, the developed method analyzed all 25 requirements within 25 seconds, uncovering 6 contradictions, including one that was not detected by any participant. This underscores the potential of the proposed method to significantly improve the efficiency and accuracy of the software verification process. The method's limitations and assumptions are acknowledged, with future research directions including integrating natural language processing, NLP, to enhance its capabilities and conducting more comprehensive evaluations with larger datasets and diverse participant expertise levels. The need for further studies to assess the overall effectiveness and applicability of the method in different software development contexts and scenarios is emphasized.